Hi, everybody, and thank you so much. Wow, the first the last trimester for the advanced math class, and we are starting with lesson 7.1, which is equations with variables on both sides. So the standard is the California Common Core State Standard, eighth grade expressions and equations, number 7. And what is it that you need to be able to do? Well, you need to be able to solve linear equations in one variable. But the essential question for today is how can you represent and solve with the variable on both sides? So we're going to do this explore activity. And so I don't know if in seventh grade you guys use modeling, what is it? Modeling tiles for the equations. And so today we're going to start off with modeling equations with variables on both sides. And so if you have something like this, that shows that it's a 1. Something like this, it shows that it represents a -1. And remember that if you have a negative and a positive, that makes a 0. And so in this case, the long ones represent the x, okay? The long tiles. If it's red, then it represents -x, okay? So those are the tiles that we will do. And so on this one, it says use the algebra tiles to represent to model the equation x plus 5 equals 3x minus 1. And so when you have x, remember that's the long one right here, the long one. And then plus 5, that means 5 positives, 1, 2, 3, 4, 5 positives. And then this one, the 3x's, 3 long ones. And if it's a -1, then that means it's red, -1. So this is how you model. So it says you modeled it, and then it says 3x plus, so remember that on this, okay, 3x minus 1 has the same value as 3x plus, I could have also put -1, okay? Now, what do you do? What do you see first? Okay, so for me, right here, what stands out before the little ones, I see the big ones, so the long ones. So then I see that there's one here and there's one here. So what I can do is I can take it away, and then I'm going to be left with, so taking it away, that represents the minus x. You are subtracting x from both sides. Ooh, let me show you on the equation. So if I have x plus 5 is equal to 3x minus 1, and this is my equation, this stands out to me. This is what stands out to me. And I see, this is the little one. So I'm going to take away that one. I'm going to take away 3x. I'm going to take away 1x. And whatever I do to one side, I got to do to the other side. So I take it away. This becomes 0. Then this becomes 5 equals 2x minus 1. See right here? 5, 2 x's, and then the minus 1. Now what do? You want to get rid of that minus 1. So you add 1 to both sides. Right here, I'm going to put it right here, my equation. Let me see. Okay, so you have, what is it? 5 equals 3x minus 1. So what I'm going to do is I'm going to be adding 1 to both sides. So I go plus 1, plus 1. This is my equal sign. So 5 plus 1 is 6 equals 3x, and this becomes a 0. So now I'm going to, oops, this was supposed to be 2x, I have 2x, this makes a 1, and so I have 2x equals 6. So that means that each tile here represents 3 of those. So in math, what we do is we split it up, we divide it by 2, and so that's how we get x equals 3. So one x tile is equivalent to, separate into 2, to 3 of these 1 tiles, okay? So the solution is x equals 3, okay? Now, it says, how can you check the solution for, the next question. Let me see, right here, so that you could see it. So right there, it says, how can you check the solution to x plus 5 equals 3x minus 1 using algebra tiles? I don't know how to do it with using algebra tiles, but I can check it. And let me show you how I check it with just numbers. And I'm going to put my work right here so that you can see it when I check it. And you should always check because that's the way you know that the correct answer, what the correct answer is. So you have x plus 5 equals 3x minus 1. And we said that x was equal to 3. So what I'm going to put is I'm going to substitute. Instead of x, I put 3. I keep everything else the same. 3 plus 5 is 8. Now on this side, I'm going to have 3 times 5 minus 1. No, sorry, the x is 3. 3 times 3 minus 1. 3 times 3 is 9 minus 1. That gives me 8. I know that these two are the same, so I know I got it corrected. Okay, so I do it this way. I'm not going to do algebra tiles to check. Okay. The next big question is, so it says solving an equation with variables on both sides. Now without using algebra tiles. It says equations with variables on both sides can be used to compare the cost of real world situations. These, to solve these equations, use inverse operations to get the real variable terms on one side of the equation. So it says example 1. Andy's car rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee 36 plus an additional 28 per day. For what number of days is the total cost charged by the companies the same? Take a deep breath. Let's read it again. Andy's rental car charges an initial fee of $28 plus an additional $30 per day to rent a car. This reminded me of the y equals mx plus b. Which one is the rate and which one is the flat fee? See, the initial, that's my y-intercept. This is my slope. Now I get it. Now I know how to do it. Now it says Buddy's rental car charges an initial fee of 36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? So on this one, the initial fee was $20 plus $30 per car. So that means $30 per whatever car is. Usually we use X instead of C. But I'm going to go ahead and put C just for now. Equals, now this one, it says they charge a $36 initial fee plus a $28 per car. Okay? Now, what you see and what I see is different things. So what I do is when I look at these two equations, my eyes go directly to the variable. This one and this one. This is the variable term. So then I highlight it. I say, which one is smaller? That's the one that I'm going to move. This one's smaller, so I'm going to move this one over here. So the inverse of addition is subtraction. 28c. I subtract 28c from both sides. So now I'm going to have 20 plus, right here, plus because 30 minus 28 is 2c equals 36, and then this becomes a 0. Okay? So now I want to get the c alone. So what do? The c is being multiplied by 2 and then added by 20. The last part was adding by 20. So the inverse of adding by 20 is you subtract 20. Subtract 20. And then you get 2c equals, 20 minus 20 is 0. So then 2c equals 16. And then this is being multiplied by 2. The c is being multiplied. The inverse of multiplication, oops, sorry, I wasn't showing it. I was so focused on solving it. So anyways, 20 plus c equals 36. I subtracted 20 from both sides, and I got 2c equals 16. Then I divide both sides by 2, and so I get c equals 8. Okay, so my cost of the car, the days, how many days? In 8 days, the cost will be the same. And I can check, look, I'm going to check. 20 plus 30c, is that equal to 36 plus 28c when each car is after 8 days? Let me see. I'm put a line right there. So I'm going to have 30 times 8, 8 times 30. This is the way I go about. 3 times 8 is 24. That's 0 plus 20. And then that's going to be 260. So this one is 260. Now I got to check the other one. 36 plus 28 times 8. This one's a little bit longer. So 8 times 8 is 64. Carry a 6. 2 times 8 is 16. Plus 2 is 22. Plus 36. 6 plus 4 is 10. Carry a 1. 3, 4, 5, 6. And then this is 2. Well, it checks out. It is correct. Okay? So that is correct. Any questions? Let me know. So now the next question, oh, guess what? So when we do the math class, you guys are going to do this one, okay? The next problem is writing a real world situation from an equation. So, oh my gosh, we got to get a real world, okay? So remember, you have the equation 15 plus 2x equals 55x. Remember, y equals mx plus b. This is the initial fee, and this is the rate, because that's the same thing as the slope next to the x. This is a, what is it? Non-proportional. But this one is proportional. This one only gives you the rate. So, what can we talk about the rate about? Okay, rate. Um, I don't know. What would be 55? 55 miles per hour? Ah, a car is traveling 55 miles per hour. For this one, it would be a car is traveling 55 miles per hour. That's what I'm thinking. And this X represents the number of hours. Okay. Now this one, maybe a bike. A bike. Wait. Okay. It was 100, 150. And this was 25. Yeah, a bike. I messed up. Okay. My second mistake. Anyways, who's counting? So I just thought of 55 is 50. It reminded me of a car traveling 55 miles per hour. The X represents the number of hours. Here, the initial fee or the initial distance. So how about if I say this bike? A bike is ahead 150 miles, and it is going 25 miles per hour. And then a car is going 55 miles per hour. When will they meet? Be at the same location? Okay. So that's what I'm thinking. This would be a bike. So a bike is 150 miles away, and it is going, a person in a bike. A person in a bike is 150 miles away, and it is going, and he or she is going 25 miles per hour. Okay. I am driving a car at 55 miles per hour. When will I reach the bike? The person in the bike. When will I reach the person in the bike? The person in the bike. That's what I'm thinking. Okay. What do you guys think? Okay. So anyways, go ahead and try it out and then let me know if you get it.